I'm going to go through the 2003 T3 question 8. It is on the goodness of fit test for chi-squareds, and it's talking about tomato plants. What we have, so it's the T3 2013 paper, and it was published, sat on in January 2014. We're told that we have some tomato plants, and one of the classes were tall plants and they had cut leaves. There were others that were tall with potato leaves. Compared to tall, there were dwarf plants that also had cut leaves, and there were dwarf plants with potato leaves. Now they were the different classes we had. After the plants grew, then it was found that there were 926 of them in the tall cut category, 288 tall potato, 293 dwarf cut, and 104 dwarf potato. Now these plants were grown from crosses of plants that were tall cut, but genetically we knew that they were what we call heterozygous. Now you don't need to know the genetics of them, but we are told that tall is dominant, and we're going to use a big T for that, to cut, dwarf. It's recessive and it has we're going to give it a simple little t. Cut is also dominant, and we're going to give that a big C, and potato leaf, we're going to give that a little c. So what would we expect from that? Well, being a geneticist, I know that we would expect, if it is true that tall is dominant to dwarf and cut is dominant to potato, and we have genes that are on different chromosomes, then we would expect offspring in a set proportion, if we had enough of them, that is. We would expect them in what we call a 9:3:3:1 ratio, and these would be tall cut, tall potato, dwarf cut, and dwarf potato. What we wanted to do in this question is we want to find out, well, are there plants that we're seeing following this particular ratio? If we were geneticists, that would lead to lots of other implications, but just statistically that's what we want to find out. So what I can see is that my ratio of 9:3:3:1 adds up to 16 components. So I would expect 9/16 of them to be in that first class, 3/16 in each of the second and third classes, and 1/16 of them in the fourth class. Now what I'm going to do is I'm going to summarize all of that and carry out a chi-squared test to compare our observations with what we expect. So I'm going to draw up a chi-squared table. In my first column I'm going to put the classes. Now because of space I'm going to shorten these down a bit. In my next column I'm going to put in my observations of what I've seen. I had 926, 288, 293 and 104. Now when you're drawing this up, make sure you put the classes in the same order as what you've done up there, or if you put them in a different order, then make sure you put the right numbers, observation numbers, with the right class. Now I know that all that adds up to 1,611. In my third column and my fourth column I'm going to put my expecteds. In the first one, I'm putting my ratios. I had 9, 3, 3, 1, and I know that that adds up to 16. So how do I work out my expected number? I'm going to show you how to work out the expected number for the first class, and then I'm just going to write in the answers for the other three. But you can verify that yourself. So how do I work out my expected number for big T, and cut? Well, I take the total number n and I multiply it by the proportion. So I expect 9/16 by the probability, and I expect 9/16 of that. So I've got 1611 times 9 divided by 16. Now I could have converted 9/16 to a fraction, to a decimal but it's just as easy on the calculator to work it that way. So what I'm going to do is I'm just going to take my 1611, I'm going to multiply that by 9, and then I'm going to divide it by 16, and I get 906.1875. Now it's quite important that you keep decimal places in there. You don't round that off to 906 even, because this is what we would expect on average if we repeated the exercise again and again. An instance, if we didn't have 1,611 but we had 1,611,000, then we're multiplying that by 3 lots of 10, so by 100. So this would be 906,187.5. So that would add in another 187.5 plants to compare against our observations. So it's quite important to leave in the decimal places if you possibly can. So I'm going to go back to my table. I'm going to write that number in here. Now what would have been easier if I'd started at the bottom, and if I had just taken my 1611 and divided it by 16, I get 100.6875. Now if I multiply that by 3, I would get the next category, which is 302.0625. In actual fact, I get the next two categories, 302.0625. Then if I'd multiplied that number by 3 again, you can see I get back to the 906.1875. Right, now what do we do now? Well, now we're in a position to compare our observations with our expecteds. In other words, carry out the chi-squared test. To do that, we take our observation, we subtract the expected number for that particular class from it, we square the difference, and then divide it again by the expected number. So as I've got 906.1875 in my calculator, and it doesn't matter because we're going to square the difference, it doesn't matter which one I take away from the other. I'm going to take minus 926, and then I'm going to square it, and then I'm going to divide that by 906.1875, and that gives me 4. Now I'm going to round that off, 0.433. What I might do is just write that out for you in this format. Just so you can see what I did. But I'm not going to do that for the next ones. I'm just going to write the answers down that I get. So I've got 288 minus 302.0625 equals, I'm going to square the difference, I'm going to divide it now by 302.0625, and I'm going to get 0.655. Now this one, it's not exactly the same this time because we have a different value here, so we're going to get a different difference even though we're using the same expected number. So now we've got 293 minus 302.0625 equals, we're going to square the difference, we're going to divide it by the expected of 302.0625, and that gives me 0.272, 0.272, and then I've got 104 minus 100.6875 equals, square the difference, equals, divide it by the expected, which is 100.6875, and I get, rounding that off to 3 decimal places, I get 0.109. Now these are just partial chi-squared, so what I have to do now is I have to sum them to give my chi-squared, which is, I'm going to clear that because, and I'm going to take 0.433 plus 0.655 plus 0.272 plus 0.109 equals 1.469. Now what we want is, what we want to find is what's the probability that we're going to get a chi-squared value greater than 1.469 given that our null hypothesis is correct. Sorry, that's a straight line. Given that our null hypothesis is correct. So what we do is, well, we could look at a comparison number, and I know then what that would be, because I could look it up on a computer, or I could look it up on a table, or we could use a CDF, and in the exam a CDF was given, but it had 3 lines on it. It had one for degrees of freedom of 3, 4 and 5. So what line on that CDF do we need to use? Well, we need to work out the degrees of freedom, and that's the number of classes minus 1 for a goodness of fit test. We have how many classes? 1, 2, 3, 4 classes. 1, 2, 3, 4 groups. So we have a degrees of freedom of 3, which in the exam paper, the graph, that CDF graph that was given, that was the solid line at the top. I used 1.5, so I rounded this off a little bit more because it was a bit difficult to do it any finer than 1.5, and I haven't got the paper with me to show you, but the probability that chi-squared was less than 1.5 was approximately equal to 0.32. But that's not what I want. I want the probability that we're going to get a difference between the observed and the expected by chance. In other words, under this, the difference is just due to chance rather than something wrong with our reasoning behind giving us our 9331 ratio. So we need 1 minus that. So the probability that the chi-squared is greater than 1. I'm going to go back to the 469, given that our null hypothesis is correct. In other words, we do have the right genetic conditions to give us a 9331 ratio, is equal to 1 minus 0.32, which is equal to 0.68, which approximately equal to 68%, because these are all approximates. So the conclusion we could make is that yes, the chi-squared does, the data does conform or is supporting the hypothesis that the plants will be in the proportions of 9/16 tall cut to 3/16 tall potato to 3/16 dwarf cut to 1/16 dwarf potato.